more examples of integration. Let me call this integration part 2. The last video should be part 1, right? Integration part 2. Okay, this example is this. Okay. Integration dx, the denominator is 7 plus x squared. I have a formula. Let's compare this question with the formula. The formula is this. The formula is integration du divided by 1 plus u squared is equal to arctangent u. Of course, you need to add a constant. So this is my formula. Let's compare. The big difference is that there is a 7 here, but the formula has only 1. Okay, how can I make this 7 to be 1? All right, let's do this now. Factor out the 7 in the denominator. One plus x squared over 7. So that's what I have. I factor out 7. Okay, 7 times 1 is 7, right? 7 times this part gives you back x squared. Now compare. 1 plus. So this part is my u squared. So I want something squared, which is this. So I rewrite this. Seven here. So this I want the whole thing square. So I can write this way. X over square root 7, the whole thing square. Correct? X over square root 7, the whole thing square, gives me x squared over 7. Now I have 1 plus u squared. 1 plus u squared. Let's put another bracket here. All right. But if I call this u, I must have u here, but I don't have u because u is x over square root 2. So I want to make this part the same as x over square root 2. How do I do that? I want dx over square root 2. This is what I want, because the bottom in the bracket is x over square root 2, the whole thing squared. If I can have this, then I have du 1 plus u squared, which is similar to this part. I still have a 7 there in front of this bracket, but I cannot just rewrite this as x over root 7. I must multiply this thing by root 7. Because root 7 dx over root 7, you cancel root 7 and this root 7, cancel these, and I get dx. So that is a trick. Let me say it again. I want this part to be the same as this. So I divide x by root 7. Therefore, this part is the same as that part. But then I need root 7 here so that I can cancel that. Oh, I'm sorry, I made a mistake. It's not 2, it's root 7, okay? Sorry. root 7. Root 7. By mistake, I put down root 2. It's not root 2, root 7. Okay. Root 7. So I must write a root 7 here so that this root 7 cancels this root 7. I go back to dx, which is what I have here. So now I have du 1 plus u squared. Then I can move the constants outside the integral. And I have dx over root 7, 1 plus x over root 7 squared. And very obviously, I achieved the formula. So here, my u is x over root 7. So u here, u squared here. Once I have the u, I can use my formula here. The formula here. Okay, this is the formula. I can use this. So I have du 1 plus u squared. Square root 7 divided by 7 can be reduced to square root 7 at the bottom. And then this, you do the integration using the formula, it's arctangent. And once I do the integration, I must add a constant. The constant is called integration constant, or constant of integration. Now, my question started with x, so I need to go back to x. I cannot stop with the u there. I must go back to x. What is x and u relations? This is the relation. So I replace u by x over root 7 plus c. So I can do nothing more. This is my final answer. Do you follow? If you have any question, call this. Call this number or text message me any questions, then I will do my best to answer it. That's it for this part 2.